for the generative design presentation, we walk through the process of performing a generative design study on an example. This is the example that I use most frequently. It's just basically a caster that is created. We walk through creating what they call preserves and obstacles. Those are two main elements to a generative design study. A preserve is geometry that needs to be retained in the final design, and obstacles are things that the final design has to avoid. So in our case here, there's a few preserves around where the axle would be in the caster on either side, and then there's obstacles here for where that is going to connect into whatever this caster connects into, and then there is another one for the wheel. Once we jump into the generative design workspace, there are a couple other types of obstacles we can create. One of which is what they call the connector obstacle, which is really great for hardware. The axle was something that I could very easily recreate with a connector obstacle, so we do that as well. And we just basically have to define our preserves and our obstacles. We also have to define our load cases. Let me kind of turn a few things off here. So basically here are the preserves. The load cases are defined against the preserves, where we have forces and things like that acting against it, where things are then also constrained. You can see here I have 5 different load cases. And mostly what's happening here is the force on the upper pin here is being changed in terms of the angle it's interacting with that. And then the last one is actually a moment as opposed to a force acting on the pin. One of the other great things about generative design is that it is manufacturing aware. So I can go into this manufacturer command and let it know what types of manufacturing methods I'm considering for this component. You can see I have things like additive, milling, 2-axis cutting, die casting, and then there's also another option here called unrestricted, where it just tries to find the best possible outcome regardless of manufacturing method. We can also define materials that we're considering, and these materials can be specific to a specific manufacturing method. So if I go into additive here, I can say which materials I'm considering for the additive workflow. If I went to the milling, I can say these are the materials I'm considering for the milling workflow. Once we have all those defined, we can run through a pre-check, a preview, and then generate the study. This one already is kind of in the process of being worked on. So you can see I have a variety of different outcomes. They give me a couple here at the top that they think are the best possible outcomes. I can filter these on a variety of criteria. On the left-hand side here, I can say, well, just show me all of the additive ones and turn off the ones I don't care about. Or I can go into something like the mass or a stress factor or a safety factor and kind of then explore these. I can actually pick on one and get a better look at it. If there's one that I really like, I can tell it to create a outcome of a solid part or a mesh file. Here's actually one that I generated from that. It's actually a free-form shape that I can then take a look at, and I can edit and make some changes. Some generative design outcomes are editable. Most of them are. There's a few cases where I've seen where they're not, but you can actually look at editing these, and then you can also jump into the simulation environment on one of these outcome files, and it actually has all the load cases predefined because it copies them over, and I can run that again and make sure any edits I've made are no longer going to impact this component in a negative way.